Welcome back guys to my new video on O-level biology. So today we'll be discussing on two type of enzymes that are used to cut the DNA from the plasmid of a bacteria. Alright, so first of all we'll be looking at restriction endonucleases. Restriction endonucleases. This enzyme is called endonucleases. Okay, so this enzyme is the cutting scissor, you can say scissor enzyme. This is your scissor. Using this restriction endonucleases, we cut the DNA from the plasmid of a bacteria. Alright, let's go for ligases enzyme. These are called DNA ligases. Okay, so this is your glue. This enzyme is used to stick the DNA onto the plasmid. Alright, now let's consider how this restriction enzyme it works. Okay, so this is your DNA strand. Let's consider this as a DNA strand. Okay, so these are the bases. We are drawing the complementary bases, right? C, G, here T, here A. Alright, so this is the DNA strand. Understood? So the restriction enzyme is used to cut this strand so that we can extract the required base sequence from a DNA. Alright, now see how it works. Now you have to understand there are two types of restriction enzyme. One gives a straight cut. Okay, the second one, it gives a staggered cut. Alright, so don't worry, we'll be discussing on straight and staggered cut. What do you mean by that? Okay, to understand, let's draw a base. Let's draw this. Okay, so here it's A. Let's write it as C, G, T, T. Let's make it little bigger, G. So what are the complementary bases? Here it's T, here it's G, here it's C, here it's A. Right? Here it's A. Now here it's C. Okay. Now, what do you mean by straight cut? Straight cut is the enzyme will cut in this manner. It will cut in this manner. It will cut from here. Okay, let's give it another color. Okay, the enzyme will cut through this. Okay, so it will make two halves. The straight cut, this is for the straight cut. Okay, it will cut straight. It will cut as a vertically. Understood? So the straight cut enzyme, restriction enzyme, okay, it will cut vertically through the DNA strand. Okay, so what you get from here, then you will be getting in this manner. See, you will get this A, C and G here. Then here you will be getting T, G and C. Okay, and this one, see, it's separated. You'll get here T and G, and here you will be getting A and C. Understood? So they are separated. Alright, then you can use this any of these base sequence, okay, for sticking into the plasmid of a bacteria so that the bacteria can produce the desired product. Alright, for you. Okay, so this is for the straight cut enzyme, restriction enzyme. It works in straight cut. Okay, now let's go for staggered. Okay, let's give it as green. Okay, let's go for staggered. Suppose this is your base sequence. Alright, so this is your base sequence. Suppose here it's T, it's A here, it's C, it's G, then again it's T, it's A. Alright. Okay. It's G, it's C here, then it's A, T. What do you mean by staggered? Okay. The enzyme, it recognizes this TGA. You need the TGA base sequence. Suppose you need the TGA that is needed. Alright. So what this enzyme will do, it will attack here. It will attack here. Okay. So it will come in this manner. Okay. And it will cut it. Alright. See. So this part is gone. So what is remaining? Let's write it in green, since it was in green. This is remaining. T is remaining. C is there. Then you have A, you have G. Alright. So these are the bases. Okay. Then you have A here. You have C. And again you have T. But see, the TGA has lost. Alright. So the base is gone. T, G and A, it's gone. So you can take off this base sequence and you can stick in the plasmid of a what? Bacteria. Okay, using the ligases enzyme. So you will be using this enzyme. It's this DNA ligases enzyme. This DNA ligases enzyme. You will be using this enzyme to stick this base sequence into the plasmid of a bacteria. This is basically the thing about restriction and ligases enzyme. Okay, there are two types of restriction enzyme. One cuts in a straight. Okay, it will give you these two product by cutting straight. Then you have to stick the whole this base sequence into the plasmid. All right. While in the staggered way, what it does, it cuts in a zigzag manner. Okay, it will cut the zigzag manner and you will get this. Understood? Clear? Now there is a point you have to understand. These restriction enzymes, they recognizes certain base sequence. So there are 1,000 kinds of what? Restriction enzymes. Okay. So each of the enzymes, they recognize a certain base sequence. What do you mean by base sequence? Suppose the enzyme used here, okay, the enzyme used in this case recognizes TGA. If TGA are arranged horizontally, then only it will cut. Okay, so this enzyme, it recognizes TGA base. Okay, so understood. So the restriction enzyme, it works in this manner. While in this case, what happens if TTG and their complementary base AAC are arranged? Okay, if this base is there, okay, then only the restriction enzyme will recognize and it will cut. Understood? So that you got this, right? Clear? So this is the basic technology behind the restriction enzyme. Restriction endonucleases, they recognize certain base sequence. Okay, there are thousands of restriction enzymes, different types of restriction enzymes. Alright, now you have to select what kind of base you need and you have to select the right restriction endonucleases enzyme. And the work of ligases is just you get the base sequence and just stick it into the plasmid of what? Bacteria. Okay, let me show you for a bit. This is the plasmid of a bacteria. A plasmid of bacteria is round. Alright, so what happens? A restriction enzyme will cut this part. So this you can say this yellowish part will be cut. This yellowish part, it will be cut. Alright, so what's remaining? It will be an empty space here. Alright, clear? So this is the, suppose you want to stick a TGA sequence in this here. Alright, you want to stick this TGA here. So what happens? You use the ligases enzyme. Alright, let's give that as red. Okay, so Ligases enzyme will stick this reddish TGA sequence into the plasmid of what? Bacteria. And again you transfer this plasmid into the bacteria, and that bacteria will give the desired product because of this TGA code. For an example, there is a thing called AAT. This sequence, it produces insulin. It produces insulin in human being. If this sequence is together, it produces insulin. Alright, so what happens if you stick this AAT sequence here into a plasmid, and when you transfer this plasmid into a bacteria, what happens? That bacteria will start producing insulin for you guys, right? For humans, they will start producing what? Insulin. So this is the basic technology here. Okay, it's very simple, clear? Share the video, and yeah, don't forget to subscribe my channel, so because more videos will be coming.